Okay, okay. I have absolutely honest and true answer, not me.
Not me, but here they are. Yeah, here they are. So we want co-ship astronaut. Ah, okay, good. So we have the next generation is here with us.
Well, anyway, there's still enough time to change your minds.
Okay, excellent.
Okay, should we move on?
Yeah.
Yeah,
Okay.
it was a pleasure. Thank you so much.
you.
Okay.
Wow.
Okay. So, in this topic of entrepreneurial space, where everyone's roles are redefined, I think it's worth a question, how do you define astronaut anyway? So what do we mean by cosmonaut or astronaut? Well, the original astronauts were test pilots. They are still dominated, the astronaut corps, by pilots, but now those cover other skill sets. What will be the dominant skill set in the future? So I would like to turn this over to JL, who will be the moderator. I'll keep the other speakers more or less in theme. And what the format is, we're going to raise a lot of questions, and the three are going to give their opinion about it, because we think this is a very important topic. So, JL?
So I think we need Janice and Bernard to come over.
Okay.
I think we should introduce ourselves.
Yeah.
I have the mic, so I'll start. I'm J.L. Galace, and I'm a recovering asteroid astronomer. I'm now a new space entrepreneur with a company for asteroid prospecting, because I believe asteroid mining is going to be a thing in the future, and they're going to need to know what asteroids to mine.
Yeah, good afternoon. In Latvian, my name is Jānis. In English, I'm Janice. And as the minister said, I'm not a scientist, but I'm from the crazy people group who dreaming about space and making first Latvian amateur space rocket.
Yeah, so I'm Bernard Frank. I worked at the European Space Agency. And I think we are all astronauts, because we are astronauts from spaceship Earth. And we all travel at 30 kilometers per second around the sun. At what a speed. So we are all together on this ship. And okay, some of us go 100 kilometers above this, so they had their speed, but we are all part also of the construct. We come from stars, we come from the Big Bang, so we have been to the universe. We are made of star stuff. So we are all astronauts. And now some of us prefer to be on ground, some like to be in zero gravity, but it's just a small difference. Okay, we take our seat, fasten our seat belts, we are going to the moon.
So, Mara's bringing up the subject of Space 4.0, and I was trying to think, how do we define what that means? So, looking at us, I think that, Bernard, don't take it as an offense, but you're Space 1.0. You're wearing a tie.
I started as an astronomer, so that's Space 0.0, where we observed the targets, and then we sent some probes. So one of my baby went on the moon,
And I worked on it.
And so it was a robotic baby. We call it Smart One. Another one went to Mars, and now we are Space 4.0. This is how we engage all of you to live your destiny, which is being an astronaut on spaceship Earth.
Yeah, so I think I'm not wearing a tie, but I'm still wearing a jacket, so I'm probably Space 2.0 or 3. And Jānis here clearly is Space 4.0, right?
Very good. No, but this is our astronaut suit at ESA.
It is. It's official. So, yeah, so as we move to the democratization of space, what exactly do we all, because I'm asking myself this question, but I'll start with you, Bernard. What do you think that means?
Well, space now is even more part of our life. Just switch off all satellites for one day, and you will realize your life is going to become a hell. So space is embedded in our daily life now.
So, but democratization kind of implies that it belongs to everyone. So we all benefit from it, but how do you think we can make space belong to everyone?
Well, space belongs to you because you are paying tax, and for what government do, we work for you. And even if you don't pay tax, you are entitled also to have benefit from it, because we want to also go to the next generation, and so our task is to make space of benefit to you.
And Yanis, you are building a rocket with other people, so please tell us about that, because that's a lot cooler than what I'm doing.
I think we are kind of the generation who dreamed about space, and since there is internet, since there is a hackathon, since scientists like you have done a lot of job, and there is lots of information, and it's time of do it yourself. We don't feel limits not to do it, and I think this paradigm of having very expensive space missions and having very expensive satellites costing of millions, it's not like over, but there is this parallel movement of people like we, and we just do the rocket because we feel like astronauts. Even our rocket is not non-piloted. By going up there, we feel we are actually astronauts.
And you can explain a bit more about the rocket itself.
Yeah.
Timeline.
So, for those who do not know, and yeah, first of all, greetings from Paul, who was supposed to be here but got a bit ill. He's head of our mission. But the idea was some years ago when we also, as you said, launched our first probe with a balloon, which we felt was a great accomplishment for Latvia. Then in our after party, we thought, yeah, probe is just like a simple thing. Why shouldn't we make a rocket? And because Latvia will have 100 years of celebration and open space is considered to start at 100 kilometers, we thought, okay, let's maybe try to make a rocket, amateur rocket, non-piloted rocket, not ballistic rocket, but just this high-power amateur model rocket with limited funds, but with some support and with some smart people in our team. And the timeline is we hope we could do it for the next year, hopefully until our country gets 100-year birthday. And we have had 9 rocket launches, 2 or 3 failed, which is good because we learned a lot. And at this stage we are even certified, because to be amateur you need to have some kind of certification so that we are able to buy these high power motors already. And we are almost supersonic now, and we failed on 9th of September to have first supersonic flight, but this is still task for October.
Wow, that's amazing. So congratulations for your work. I was myself, I did my PhD on using a sounding rocket, so it worked. And at the end of my PhD, I prepared a launch campaign. But one of my colleagues had to launch 5 times this rocket to get the result for his PhD. So I was lucky at that time. And so, but now we have a spacecraft that can also be used to, you put a scientific experiment on it, and the data are shared among all scientists over the world. So that's also another aspect where we can democratize how you access the data that we are producing for everybody, observing the Earth, also exploring planets.
Yes, because nowadays pretty much all missions have publicly accessible data. Maybe not immediately, but at some point it all becomes public, and citizen scientists can access it. And you're looking at me, Amara, like you're going to play a video.
Do we want to show a rocket?
Yeah.
Yeah? Okay, so we're going to show one one of these 100-kilometer rockets right now.
Yeah.
Okay? With the sound as much as we can.
Pievienojot deguna pirmo kontaktu. Aiziet. Check.
Yeah, this is our first public launch on 20th of April, and this is our mission command
Aiziet, starta procedūra.
chief engineer, and
Mēs tagad atrodamies misijas vadības teltī.
this is
Šī raketa ir Zēns.
Jā, šī raketa
Vakar bija Resnā Zēns. Šī raketa
name
saucās
of the
Zēns.
rocket was Zenta, which is a Latvian name, but some people think we made fun of Ventspils, but I don't know. So this is our launch station, and some data, we had some video, weight just 4 grams.
5, 4, 3, 2, 1, aiziet!
Yeah. For us as astronauts, it's very emotional because we worked since October and April, and finally we had the launch. This is LMT. This is our main sponsor, mobile phone company. Network. This is Slow-mo. Yeah, our first flight was immediately, how to say, historical record of all the amateur flights, because we reached 1.8 kilometers, and for us it was a high-tech rocket because everything inside of it was very, very small. We did not use any electric solutions. We had ideas from the internet, but we made all the motherboard plate ourselves, and we made the body, we made all the stabilization,
Tas ir tas, ko mēs vēlējāmies
and
sasniegt.
only
Šī
rocket
brīdī.
motors
Viss ir nostrādājis, viss ir atvērties, var ielādēt jaunu motoru, un mēs
for
to
safety, etc.
Aplaus lūdzu Andrejam.
Tā, raķete ir perfektā kārtībā.
Yeah, and
Viss
he
tas,
tells
kas
that
bija plānots,
rocket is in
nostrādāja.
perfect condition, which was true.
Principā mums tests ir izdevies.
Parachute was ejected successfully, and it landed on the same airfield. So.
So how big will the rocket get?
How big?
Yeah,
It was 1 meter, less than 1 meter.
but are you going to make them bigger?
Those next launches were already, it was a bigger rocket, like 1.5 meter, and it was bigger in diameter and more heavy, and yeah.
Have you already launched one that looks like the one that's outside?
That size would go for the next spring, but this is just a model.
Yeah. So I encourage everyone to take a photo, a selfie with that rocket. And you're talking about astronauts. You're Latvian. So I went to look at where we've had astronauts from, like who's gone into space. And there have been a little bit over 500 people in history that have gone above the 100-kilometer line into space, and 45 nationalities. And there have still not been any Latvians. So you guys... Sorry? Oh, soon. Yes, exactly. So, I mean, that means that, there's a window open there. Now, I don't know if unfortunately or fortunately there was one Lithuanian. Is that a good thing or a bad thing? Yeah? Okay, good. I don't want to step on any toes. So, I wanted to continue with the democratization of, and I always get stuck on that word, democratization of space. Because right now, like Amara said, everybody that goes into space, or most people that go into space, tend to be test pilots. Now we have more scientists going up to the ISS and performing experiments. But in the early Apollo days, they thought that it was only pilots who could go into space. But as more and more people go into space, as we make it cheaper, as we have private space, normal people like me, like us, we're going to be going into space. Now, when we actually start establishing habitats in space, and this may be a few decades away, but that is what we're dreaming of, then you're not going to have to be a space pilot to go into space or an engineer. In fact, they're going to need architects and plumbers, for example. So there are going to be a whole host of jobs that are going to be required, and maybe the smallest amount of astronauts will be pilots or scientists.
It's already the case. I mean, we are moved much beyond this phase. Now you have a different task for astronauts. You have a commander task, which is good to have a pilot background. But we have what we call payload specialists. These are those people that are operating various experiments. So we have much more payload specialists now, and so they need to operate experiments. They have a training in science and engineering. Some of them biomedical training. That's also important to have. So there is already quite a large category of astronauts, and this is going to be even more open. Now, in case many of you are also controlling IT device, so that will be an asset there. So then the next generation, we had the politicians, so we had the senators going in space. So I think it's also going. You need to operate, experiment, but also what is important for astronauts is to go there and tell the story of what they have experienced, because this is the reason why they make also difference compared to robots, because they they engage the rest of the community. Otherwise, I love robots, but there is some part of the story which has to be told by a human to you.
Yeah, and I certainly feel that as humans we have an innate curiosity and a need for exploration. That's why we live all around the world, and I think that's why we want to go into space. Because some people feel that we maybe shouldn't be expanding into space. So maybe I'll open that question. What do you think, Yanis?
I think we should, and I think in some 20, 30 years we will be so bored of what we do now that space will be kind of only way and destination where we could go. And as you said, it will be not just for scientists, and maybe even for non-scientists. We will just need also simple labor to go and dig something on the surface of a moon or a Mars. And of course, first flights will be one way or even little, but in 50 years this will be just like a few-day return trip.
Well, it's our destiny to explore the frontiers. We went to some parts, okay, maybe humans were mostly from Africa, also a bit from Europe, we found out now, and they moved, they explored, they pushed the frontier. Now, they were forced to do that. It was a kind of, it's in our gene. And in our gene is embedded the need to curiosity, the need to see a new world, to find technical challenges. So this is the reason why also we embarked partly now in space exploration. But we have to go beyond exploration. Because at some stage, we have a moon which is so close to us. And now we have found this moon was part of the Earth at some stage. It's our 8th continent. So it's really within reach, within a few decades, that we will establish humankind having operations there. And okay, some of them will have their feet on the moon, but mostly they will do it for the benefit of everybody. And so our brain will be operating with them. And they are going to connect more and more this moon with the Earth. Now, that's a normal scenario. There are also catastrophic scenarios. If there is an asteroid that impacts the Earth and that eradicates life for 10, 20 years, it will be nice to have a refuge where life can prosper and then we bring back life. Or if we trigger a cyber war that we cannot control, or virus, it would be good to have a kind of insurance against that. But that's a catastrophic scenario. And so we need to back up possibly humans, or if we think that even if they are guilty of some of what is going to happen, to give them another chance. But at least we need to back up the biosphere.
And I think all the scientists here can understand the importance of backups,
Oh, yes.
We probably all lost some draft of a paper or a thesis. So going back to something you said, that you feel it's important that humans that go up into space, that they report their experiences. And I think one of the things that, even as a child, struck me about space and when the ISS was beginning, was how you had various nationalities living there. And even when there were problems on Earth, it always seemed like those problems didn't exist amongst individuals in space. And we have a video here. So I think one of the latest great ambassadors from space is Commander Chris Hadfield. This is his training. I don't know what year it was, but he's training at Star City.
I've been training for this flight for approaching 4 years already. And it's a really long, iterative process. And it's all simulation and preparation and visualization.
Over the past 3 years, this has become Chris Hadfield's home away from home. This is Star City, about an hour drive from Moscow, the heart of the Russian space program, the very place where Yuri Gagarin prepared for his historical spaceflight more than 50 years ago. The training center now bears his name.
That's the centrifuge. We'll be going in there. Soyuz simulators in here.
For Chris Hadfield, it's like a new beginning. Almost 12 years after his last flight in orbit aboard the US space shuttle, he gets to fly again. And his next taxi to space comes from Russia. Quite a stretch for this ex-fighter pilot who used to intercept Soviet planes in Canadian airspace at the height of the Cold War. For him, this meant he had to start again from scratch, learn the Russian systems, and prepare for his longest flight yet, 6 months in space. The training is long and demanding.
When you train for a space station flight, it is a long solo training flow for years, and you learn so many things in so many different places.
For Hadfield, one of the most daunting tasks was learning to fly the Soyuz rocket, a long and complex process. And an important one, a matter of life and death.
One of the main purposes of the training was to really understand all of the things that can go wrong so that it removes the fear. My job is at contact отdelения, when we have the necessity to separate from the rocket ship. If I notice within 15 seconds of getting to orbit that we haven't had separation, then I reach up, throw that switch, push these up, and push these two guys here. Otherwise, we may not survive.
Trouble is, of course, all these buttons that can save your life are written in Russian. So for Hadfield, mastering the language became one of the main challenges.
Сейчас я говорю по-русски, поэтому нужно говорить по-русски. Мы знаем, это русский корабль, это не английский, это не французский корабль. Потому наши профессоры, наши учебники, все только по-русски. Но вы знаете, я не говорю по-русски, я говорю по-союзу.
In Star City, Chris Hadfield was able to tap into a long and established tradition of space travel, training under the supervision of the last Soviet cosmonaut, Sergei Krikalev, a national hero here.
And how many days total have you been in space?
I mean, 6 flights.
In 6 flights.
A little more than 800.
800 days in space. So Sergei's lived in space longer than any other human being.
July 2012, Baikonur Cosmodrome in Kazakhstan. It's T-3 days. For Chris Hadfield, it's a very important moment. He's a member of the backup crew for this launch, which means he could take off 6 months earlier than planned. He's on location, in quarantine, ready to fly. For him, it's a great opportunity to see up close the space vehicle he'll soon be inside. A rocket that was designed more than 40 years ago. Old, but safe.
It's an excellent spaceship with a long, good track record, and it is one of the very few vehicles on Earth that is capable of reliably and repeatably safely taking people to space and back.
Chris Hadfield will soon become the third Canadian to go into space on board one of these Russian-made Soyuz rockets. And in the spring, he will make history as the first Canadian ever to become commander of the International Space Station. July 15 in Baikonur, Kazakhstan. Early morning. The Soyuz rocket is ready to launch, and so is the regular crew. Chris Hadfield is off the hook.
For me, standing here on the sidelines, it's one of the worst places to be an astronaut because I'm powerless.
Everything goes as planned. The crew reaches orbit within minutes.
What just happened today is right at the edge of what we're capable of doing. To take 3 people from a standing start and get them going 8 kilometers a second in under 9 minutes is just barely possible. If you're willing to kill people all the time, you could do it pretty easily. But if you want to do this safely, it is just barely possible.
Fast forward to the end of November. Chris Hadfield's training is officially over. His turn has come to ride the Soyuz rocket. In keeping with tradition, he gets to sign the guest book in Yuri Gagarin's office, unchanged since his death. Then, to lay flowers on his grave on Moscow's Red Square.
But I appreciate you scurrying.
A few minutes of sightseeing with his wife Ellen around the Kremlin. That's pretty much the only spare time he's allowed before takeoff. Soon after, Chris Hadfield leaves for the launch site in Baikonur, Kazakhstan, ready to walk again in the steps of the greatest legends of space conquest, to once more fulfill a lifelong dream.
You become an astronaut. That defines who you are. And I feel exactly the same excitement that I did as a 9-year-old boy dreaming about maybe someday flying in space.
Jean-François Bélanger, CBC News, Baikonur, Kazakhstan.
So I think this brings us to the next topic, which is astronaut training. And if we're all going to go into space, I don't think there's the capability of everyone being Chris Hadfield and spending a year learning Russian and 4 years. Well, this part, yes. Or even a professional lifetime, let's say, training to be an astronaut. At some point, going into space will have to be like getting on an aeroplane and going to another continent. I don't know how far away that might be, but let's say the next step, which is when it's not just the engineers and the pilots, but we have the plumbers and the teachers. What do you think, Bernard? As the ESA person, put on your ESA hat.
I think
how do you think the training will be?
120 years ago, it was an impossible dream to fly on a plane. And then some pioneers developed this capability, and then it's true, it was modernized and it was made accessible. So there are possibilities that, for instance, where first we are going to develop also facility to do to make use of a rocket to go to do long travel over the Earth. No, then you will cross the 100-kilometer line, and you will become an astronaut. So it will take time, of course, because at the moment it's a technology which is not very sustainable. It costs a lot of energy to leave the Earth. But it's possible that within a time scale of less than 10 years, you will have a commercial astronaut, and by paying a ticket, you will have the ability to cross the 100-kilometer line. Now, I think for low Earth orbit, this is within reach within the next 10, 20 years. To go to the moon, it's another step, but this is something that we have to prepare. So in parallel, for instance, we are looking at a project where we follow up some of the robotic development, and we look at a vision where already around 2030 we could establish a kind of advanced outpost on the moon, possibly with 10 people from various countries, also with commercial stakeholders that have a permanent presence on the moon, like we have now for the International Space Station for 10 years. And when you start this, it will be like when we have built the railway going to the far west. From that, you will have the ability to have commercial companies, private citizens, making use of this and starting a new settlement. But then so this will take time, so let's say in post-2040s.
And one question that I would like to ask an astronaut, and I have to remember next time I meet one, is how, if they feel bad that they're going to stop being part of a very exclusive club with other people going into space. You can't answer for the astronauts, but I want to ask them that question. So there's actually a company called Association for Spaceflight Training that was set up to train people to go into space, a private company. And I think that's telling that they feel that they're at that time when they can start making a profit by training private individuals to go into space. And I'm sure that some people go train maybe expecting that someday they'll go into space, but this is part of the privatization of space, where people are looking at niches and things that have to be done in order to get to space, and they're entrepreneurially going and filling those niches, a little bit like you. There are no Latvian rockets, so you guys decided, well, we're going to build a Latvian rocket.
But there are various steps to transform space. Yeah, okay, with some of the, when I was a kid age, I tried to train for space. I went in the field, far from the city, look at the stars, and then I started already to travel. And then I studied a bit of science and engineering. I built a telescope, and then later, there are opportunities. So you can feel zero gravity. You can go on parabolic plane now. You can experience for 20 seconds microgravity. So yeah, you can go step by step, and you can also study the object like the moon and Mars, and you will know about them more than astronauts do. So they will rely on you. They will ask you the maps. They will ask you, oh, how can I survive there, exploit the resources? So we will be part of the team. So they will be on the field. We will be maybe on the side bench, but we are part of the football team that is supporting what they are going to play on the surface of the moon.
Yes, no, it's definitely a team sport, and there's no one person or company that can accomplish this. Like, how many people are in your team?
We're like almost 20, and team is very important because different experience, and it's actually a big task still. Even it's amateur rocket, and it's our dream, and it's a bit of fun, but it's still a lot of serious work in the end of the day. So
I guess that this comes back to how important diverse teams are when you have big goals in mind, which I think space has done pretty well. And maybe a little bit of an outfield question, but one of the things I wonder is, what will be the most important profession in space once we have, say, the first 50 regular citizens living in space? What do you think the first most important profession will be? Because I have an answer, but I'll wait till the last one.
perhaps space miner.
I imagine that we want to have a village, and in a way, I don't know if you have lived in a village. You don't want a village with only plumbers or so. You want really a diversity of skills. You want a good diversity of gender, because you don't want to be all the same. You want a diversity of age. So clearly, when we are at this stage, when we have a moon village, we want also to feel this beautiful cultural heritage from various countries. It's a new chance to grasp how, as humans, we had so many backgrounds, and I have to learn. We can learn languages: Russian, Chinese, Latvian, because there will be some in the village, and and we can really start really exploiting the diversity of skills that we have.
So my question was a little half joking, because I think the most important profession will be psychologist. Because,
really?
Yes, because anybody that's not born up there, I think, if I were to go up there, I'd spend like the first 5 years, like, what? And I would need psychological help, like, to understand the magnitude of what we've accomplished. Because then we'll have the next generation who are born knowing that there are people up there living their everyday lives and that they can grow up and have a job up in space at the asteroids, the moon, the Mars, or floating in space in a habitat. And for them, it will just be normal. Like, my kids are never going to know a world without internet, for example. Yeah. For them, it's just going to be normal.
But you need multiple skills. Psychology is a skill that you need, but it's a skill. You need a scientific skill, engineering skill, medical skill as well. You want to be able to help your colleagues. So, for instance, I learned first aid, I learned engineering, I learned psychology as well. So you need all these skills, and you need to have a patience. So I see also this group here qualifies. They are very patient. They are listening to us. So you are part of the Moon Village now. And we have made some experiments. So if you want to train, I have put some of my students for 2 weeks inside a base, isolated from the rest of the world. And we have studied how they behave with each other. And I have some recipe for that. I give them a lot of work. They don't get bored. They have so much work. They do it, and they hate me. And because of that, they are all united against me. So that's a way how you maintain a very good spirit on the moon base.
I'm not sure about that, but is that official ESA policy? Or?
Well, it's a trick that was used for various astronaut expeditions. The control center gives them some instruction, and sometimes they want to rebel against Earth authority, Houston. Yes, in ESOC, in our operation center, we have learned lessons from the past. But that's true. Sometimes you have to help them to create this group dynamics where they are putting all their energy in a positive direction. First, to survive, to perform efficiently, and also to have an experience that doesn't become a risk for the expedition.
So you want to create unity, yeah. So
unity in diversity, though.
And diversity.
Let's talk about artificial intelligence and the limits of what humans can do in space.
Okay. So artificial intelligence and the limits of what humans can do in space. And I'm going to start with something that, a little tidbit that I actually owed to Martin. That made me think about that. So the first astronaut who was not a test pilot that went to the moon was Jack Schmitt, who was a geologist. And he went on Apollo 17, which turned out to be the last mission to the moon. And I always think how wonderful that must have been for him as a geologist to be the first of his kind to step on another body. And he spent 3 days on the moon. And then after that, we've just sent robots to explore other planetary surfaces. And the rover Opportunity on Mars took about 10 years to cover the same distance that Jack Schmitt covered in 3 days. So maybe humans are better. And I like robots too. You said you like robots. I like robots too. But that does say something. It is very difficult to send a robot to another planet and control it and do science when it's so far away and you can't control it in real time.
That depends. On the moon, it's a bit easier. It's just 3 seconds time delay. So we have tested that various places. You can really control a rover which is 3 second time delay. On Mars, no way. Because it's 40 minutes back and forth. So you say, please go there, and then the rover have to wait 40 minutes to receive the instruction. There is no way. So they have to be much more intelligent. But for the moon, you can still control them with a joystick. Because the moon is just part of, it's near the Earth. So it's part of the Earth-Moon system.
And yet it's still difficult, as the Chinese saw when they landed their rover. I don't think that they were trying to control it in real or near real time, but they had issues. I believe it didn't work as well as they wanted it.
You can deal with the control on the moon. what is difficult on the moon is very extreme conditions. On the moon, where the Chang'e 3 lander and rover were, at night, it's 100 Kelvin, minus 170 degrees. During the day, it's plus 120 degrees Celsius. So you need a very good design, and it's very dusty. So it's a very extreme environment, and that's why the rover failed. But from the point of view of control and operation, they did very well.
So they're not kicking us out, are they?
Yeah. So artificial intelligence, yes, I wanted to, that's why we were talking about robots, because before artificial intelligence, which is maybe going to invade our life now, for exploration, we will have a very strong partnership between humans and robots. And humans, many of them will be on Earth, and we'll have robots, and many of you will be able to operate, for instance, robot on the moon. But also when we'll start to have humans on the moon again, we will have a very strong partnership. We have pet robots. We will have a robot that will build some of the infrastructure. So this will be a very efficient way to use humans for their skills and use robots also that can add additional skills.
Yes, I actually think that AI is going to be crucial because if we're mining asteroids, for example, we're again going to be 10, 20, 30 minutes delay time. Mm-hmm. So the mining equipment will need to work autonomously and coordinate amongst itself. So I don't know that there is enough AI research being done in this area. And talking about remote control, if anybody wants to see how difficult it is to control something remotely, downstairs where the kids play, which is a really fun place if you haven't been to visit it, there is a simulated, well, there's a Mars rover that you can control, and you look at a little screen, and I imagine that's how it would be if you're doing remote control. It isn't real time, there's no delay, but I encourage you to try and pick up some Martian soil, and you'll see how difficult that is.
I think let's start here, and I want to invite you all to visit us at our European Space Research and Technology Center, where we are also testing robots. We develop instrument, spacecraft. So when you pass by the Netherlands, don't hesitate to come and visit us. We give you a VIP visit of our facilities.
Okay, this event was for young people, and with the rain and late night, perhaps, we didn't get the young people we wanted, except for these. Do you, Via, and yeah, ask them a question. We want to answer your question.
Why can't you just shoot yourself into space, wait until the Earth orbits into where you want to go, and then just go back down?
Why not?
What are you doing at
So, let's try. You know, with the speed here, I can go to 1 meter. So to go to reach space, I need a very high speed, a speed which is 1,000 times faster than the speed I can get with my feet. So that's why you need rockets. And we. Oh, sorry, why?
The planes.
So to go from a plane.
Sorry, he means why can't, instead of taking an airplane where you want to go, why can't you go up in a rocket and time it so that you can then come back down like a SpaceX rocket, and you just shoot straight up, wait for the Earth to spin a bit, and you go down in your destination.
That's a great idea. You should come and visit me at Aztec. Let's try to, but no, but it requires much more energy to leave the Earth. Than to fly on a plane. So for the speed of our rockets, and for the speed of a plane, let's say it's 500 kilometers per hour, speed of rocket are much faster. You need a full engine, a rocket, to leave the Earth.
And I think it'd be very uncomfortable as well.
Pardon me?
It would be very uncomfortable.
Very uncomfortable. Now, that's for the Earth, because the Earth is quite a big planet. If you would be on the moon, and maybe when you travel the moon, it's 50 times easier to leave the moon than the Earth. That's why we want to build a spaceport on the moon. And then from there, it will be easier even to go on orbit. If you would live on an asteroid, here you could jump out of the asteroid.
I have a question. I know how gravity, what gravity is, but I don't really understand how it works. I know that it takes all the air and the people, so they stay on Earth. But how does it take the air down so it can only be on like our planet?
That's true. And actually, luckily, this is what happens on the Earth. Like on the Earth, the gravity is strong enough that the gas, that air composes the Earth, actually it's moving all the time at some velocity, but the velocity of this gas is smaller than the velocity it needs to escape the Earth. And that's why, luckily, this atmosphere has stayed. In the case of the Moon, it's smaller. So, and then, as we mentioned, it's very easy to leave the Moon. And even if there was gas at the beginning of the Moon, this has mostly escaped. So there is no atmosphere around the Moon. On Mars, also part of the atmosphere that was present at the beginning has escaped, and you have only 1%. The atmosphere of Mars is only 1% the pressure of the atmosphere of the Earth. So it will be quite tough there to breathe. So we'll have to equip ourselves with artificial system to breathe.
I think we have to wrap it up because it's 2 minutes after our 8:30 ending. So I think I just want to thank all of you for braving our rainy night and bearing with us while we didn't have the teenagers in the audience and we had mixed languages. I think this was a very interesting discussion, and it's worth to pursue this discussion in the new space, in Space 4.0 arena, because we really do need to know how to include astronauts in the next entrepreneurial space. Okay, let's wrap it up. Thank you.
Thank you very much.
Great question.
Thank you.